Okay, today we're going to be talking about two different things. So first off, we're going to talk about movement and support of organisms. Keep in mind, if you haven't read chapter 25, you should do that. Make sure tonight you read chapters 26, 1 and 2. And there will be a quiz on the earthworm for tomorrow. So here's what we're going to talk about. We're going to talk about three types of skeletons in animals, and we're going to talk about how muscles help things move. So first type of skeleton, the worm, this has a hydrostatic skeleton. The pressure from inside simply pushes out. This allows for great movement and flexibility. Second type of skeleton is an exoskeleton. This is a hard outer covering, and this is made up of chitin. So the chitin is very hard, and animals that have an exoskeleton, they're required to molt periodically so that they can grow. And now this time when they're molting, they're very, very soft, and they're very, very vulnerable to predators because they don't have any hard outer covering. So hydrostatic, exoskeleton. Here's this is an arthropod. Jointed legs. Insects are arthropods made up of three body parts: head, thorax, abdomen. And the thorax is made up of three parts as well. Arthropods in the water, how do they move themselves? They flap their tail hard and they move backwards. I don't know if you've ever been lobster fishing, but you sneak up on a lobster and it like takes off backwards with one big flap of its tail and doesn't even know where it's going. So we have the hydrostatic skeleton, the exoskeleton, now we have the endoskeleton. So the endoskeleton is inside or within the body. So here's a very, very simple organism with an endoskeleton, this notochord. As you can see here, the notochord, that's the internal skeleton, or runs the length of the body, and it has a hollow nerve cord, gill slits, segmented muscles. Here's the lancelet. This is the same as the other one. This notochord is what gives it its structure. So now within these endoskeleton organisms, we have cartilaginous skeleton. So a shark doesn't have bones. Its whole endoskeleton is made up of cartilage. And we also have some organisms like you and I, which have a bony skeleton. So vertebrates that don't have a cartilaginous skeleton will have a bony skeleton with a vertebral column or a spine. And this protects the nerve cord. And these things all have bilateral symmetry. Remember, bilateral symmetry, same on either side. So bony skeleton, here we are, a fish. Many fish have a bony skeleton. Actually, bony fish make up the majority of vertebrates. So places where these bones join together, these are going to be called joints. And joints are held together by ligaments. And oftentimes you hear somebody who tore their ACL or MCL, or they blew out their knee. Okay, so what we're talking about with the ACL or the MCL or the PCL, this is an area in the knee where it holds the bones of the lower leg together with the bones of the upper leg. Now, muscles work together in groups, and these groups are opposite of each other. When one flexes, the other one's relaxing. When this one flexes, this one relaxes. Same thing with your lower leg. So when the leg is contracting, okay, bending, then this one is flexing or contracting. When the leg straightens out, then your quadricep is the one that's extending, or your quadricep is contracting. So muscle tissue is the only tissue in your body that can shorten or contract. Come on. So within your body, your muscles and your bones work together as three different kinds of levers: first-class lever, second-class lever, third-class lever, depending on where the fulcrum is. and where the force is applied. So this ensures that your body is able to do a lot more with the muscles and the bones, depending on the length of the fulcrum and the muscle being applied to it. So movement, when one muscle group contracts, it flexes the joint. When that one relaxes and the other one contracts, it straightens the joint. And so this is how organisms move. And of course, mammals were very, very complicated. We developed many ways to enable us to move. And you can see here all these different bones. All the bones of your spinal cord are connected together, and they're all working at different angles, and the fulcrum and the forces are at different spots to make movement possible. Okay, go ahead and get into Savas and do the interactivity that says, I think it says skeletons, bones, joints. So go ahead and do that right now.